This is mathheals.com, where you can find more links to math and computer science YouTube videos. Let's take a look at chain rules for functions of several variables. And we'll show it with an example here. Got w is equal to x to the third minus 7y squared, and x is equal to t, and y is equal to 2t. And it wants to find dw dt, and our formula for that is down below. So let's examine what the chain rule looks like. We take the partial of w with respect to x, times the derivative of x with respect to t, plus the partial of w with respect to y, times the derivative of y with respect to t. Okay. Well, if I was trying to think if I need to show these over on the side. Maybe I will. Let's first find dx dt. So we got dx dt. So the derivative of x with respect to t is 1. And dy dt, the derivative of y with respect to t is 2. Well, the up here, the partial of w with respect to x, again, we treat the y like a constant, so that gives us 3x squared. And then dx dt we said was 1, plus the partial of w with respect to y. The x to the third is treated like a constant, so it drops away when we take derivative. And this gives us negative 14y, and dy dt is 2. Which gives us 3x squared minus 28y. But up here, we know what x and y is. So we'll now plug in x is equal to t and y is equal to 2t. So the x squared becomes t squared minus 28, and the y there becomes 2t, which gives us 3t squared minus 56t. Assuming no basic math error. Let's take a look at problem number 2. We got w is equal to x squared y squared, and x is equal e to the t, and y is equal to e to the 3t. And want to find dw dt using the appropriate chain rule. So we'll use this formula down here. And remember, the formula is to take the partial of w with respect to x times dx dt. Now, the chain rule makes a lot more sense, I think, when you're dealing with partial derivatives than when you're dealing just with derivatives in Calc 1. Just seems to flow smoother when I look at this and you have different variables. And then we'll take the partial of w with respect to y. Those are not 2's, those are the partial derivative symbol, times dy dt. Well, the partial of w with respect to x, the y squared is a constant, so I'm going to take derivative of x squared, put the 2 out in front, lower it by 1. So it becomes 2x y squared. Then times dx dt. Well, the derivative of x is e t. A partial of w with respect to y. We treat the x squared as a constant, so take derivative of y squared, put the 2 out in front, lower the power by 1. So this becomes 2x squared y. And a partial of y with respect to t. Well, the derivative of e to a power is e to the power. That doesn't change. But if you got more than a single t up here, you have to multiply it times the derivative of the exponent. The derivative of 3t is 3. Well, that's going to give us, let's see. Well, I'll simplify and then I'll plug it in. So we got 2 e to the t x y squared plus 2 times 3 is 6 e to the 3t, and then x squared y. Double check all that. Okay, now plug in. X is equal to e to the t, and y is equal to e to the 3t. And we're going to have 2 e to the t times x, which is e to the t, times y squared, which would be e to the 3t squared, plus 6 e to the 3t times x squared, which would be e to the t squared, times y, which is e to the 3t. Well, I'll simplify. See what happens. When we got e to a t times e to a t, remember what you do when you got like x squared times x to the third? You add the exponents, and that's what we'll do here. So t plus t gives us 2t. So we got e to the 2t times e, and when you're raising an exponent to another exponent, it doesn't matter that these are e's. Remember you had x squared and you raised it to the third power? You multiply your exponents. 3t times 2 gives us 6t. Plus 6. E to the 3t times e to the 3t gives us e to the 6t. Remember, if you got e to a power times e to a power, you add the exponents. And here we're raising an exponent to an exponent. So you multiply them. T times 2 gives us 2t. Which gives us 2e. And again, we got e to a power times e to a power. You add the exponents. That gives us 8t. Plus 6 e to the 8t. And that gives us 8 e to the 8t. Okay, that was part A. Now, part B says convert w to a function of t before taking the derivative. Well, we said w is equal to x squared y squared. So we're going to plug in x is equal to e to the t, and y is equal to e to the 3t. Well, we got x squared, so we're going to have e to the t squared times y squared, so we'll have e to the 3t squared. And again, you raise an exponent to another exponent, you multiply the exponents, so that becomes e to the 2t, and this becomes e to the 6t. And e to a power times e to a power, you add the exponents. 2t plus 6t gives us 8t. Now, if I take the derivative of that with respect to t, well, the derivative of e to a power is e to a power times the derivative of the exponent. That's whenever you have more than a single t up there. That's a chain rule. For what you saw back in Calc 1. The derivative of 8t is 8, so we got 8e to the 8t. You can see that a lot of times by switching it back to just everything in terms of t's instead of x's and y's, it's actually a little bit easier to take derivative. Let's see, what's this called? Chain rule for functions of several variables. Okay. chain rule for functions of several variables. Page 01.pdf. Okay, let's look at our next problem. Got W is equal to xz minus xy. Okay, that I knew that wasn't right. Can't have xz minus xz, so xy minus xz plus yz. And x is equal to t plus 2, y is equal to t minus 3, and z is equal to t squared. And it says find the dw dt by using appropriate chain rule and by converting w to function t before differentiating. So same thing we were doing, except for now we got more variables. And you can see our chain rule is what you might expect: partial w with respect to x times dx dt plus partial w with respect to y times dy dt plus partial of w with respect to z times dz dt. Well, I know I'm going to need them, so let me go ahead and do it right here. So dx dt, if I take the derivative of x with respect to t, that's 1. The derivative of y with respect to t, the derivative that's 1. And the derivative of z with respect to t will give us 2t. Okay, so part A. I'm going to take the derivative of d with respect to t. It's going to equal partial of w with respect to x times dx dt plus the partial of w with respect to I said w, but I wrote down y. Okay, partial of w with respect to y times dy dt plus the partial of w with respect to z times dz dt. Well, the partial of w with respect to x. Again, y and z we treat like constants. So here's xy. So the derivative of x is 1, and we're left with the y, so we've got y. Minus partial of xz with respect to x. Again, the z is a constant, so the derivative of x is 1, so it drops away, and we've got z. And that doesn't have any x in it, so that just derivative of that drops away. Times dx dt, which is 1, plus partial of w with respect to y. Well, xy, we treat the x as a constant. The derivative of y is 1, so we got 1 times x, or x. This doesn't have a y in it, so it drops away completely. Z is a constant here, and derivative of y is 1, so that becomes a plus z times dy dt, which is 1, plus the partial of w with respect to z. This doesn't, the xy doesn't have a z, so it drops away. The negative x we treat as a constant, and derivative of z is 1, so that gives us minus x. And the y we treat as a constant, and derivative of z is 1, so that gives us plus y. Times z dz dt, which is 2t. And I'll simplify a little bit. So we got y minus z, the 1 doesn't do anything, plus x plus z. And yeah, I'll go ahead and multiply this through. 2t times negative x gives us negative 2xt, and 2y times, or 2t times y gives us 2y. Oops, and right to 2. There we go. Okay, let me try that again. A little bit cleaner, not so sloppy. Okay. Well, the z's cancel here. So we got x plus y minus, and then plus, there we go. Now we want to plug in x is equal to t plus 2, y is equal to t minus 3, and z is equal to t squared. So x becomes t plus 2 there, plus y, which was t minus 3, minus 2x times, and then the t was, oops, what am I doing? I'll wake up here eventually. X is t plus 2, so put that in. Times t plus 2 times y, which was t minus 3, times t. Now let me double check that. Okay, t plus 2 plus t minus 3 minus 2 times t plus 2 times t plus 2 times t minus 3 times t. T plus t is 2t. 2 minus 3 is negative 1. And then we'll have negative 2t times t plus 2. And here we got a plus 2t times t minus 3. Okay, so that gives us 2t minus 1. Negative 2t times t gives us negative 2t squared. Negative 2t times 2 gives us negative 4t. 2t times t is t squared, or 2t squared. 2t times negative 3 is negative 6t. Well, the t squared is going to cancel. Negative 4t and negative 6t is negative 10t, plus 2t is negative 8t. Minus 1. Assuming no basic math error, which we'll find because we're going to be doing it the other way now. So part B. We got w is equal to xy minus xz plus yz. And we'll plug in x is equal to t plus 2, y is equal to t minus 3, and z is equal to t squared. Let's try that again. Okay, so we got w is equal to x, which is t plus 2, times y, which was t minus 3, minus x, which is t plus 2, times z, which is t squared, plus y, which is t minus 3, times z, which was t squared. T times t is t squared, t times negative 3 is negative 3t, 2 times t is 2t, and 2 times negative 3 is negative 6, minus t squared times t plus 2, and t squared times t is t to the third, t squared times negative 3 is negative 3t squared, which gives us t squared negative 3t plus 2t is negative 1t, or negative t, minus 6. Negative t squared times t is negative t to the third. Negative t squared times 2 is negative 2t squared, plus t to the third, minus 3t squared, assuming no basic math error. Okay, here we have a t squared. Here we have a negative 2t squared and negative 3t squared. Negative 2t squared, negative 3t squared is negative 5t squared, plus t squared is negative 4t squared. Here we have a negative t to the third plus t to the third. Those cancel. And we got minus t minus 6. Okay, now let's take derivative of that and see if I come up with the same thing, or if I need to go look see for an error. Okay, derivative of this with respect to t gives us negative 8t minus 1. Which is good, because that's what we came up with over here using the chain rule. Let's take a look at this next one. Let me grab a drink here. Do I have room? Yeah, probably. Well, let me save this page just in case. Hate getting in the middle of a problem. There we go. In this one, we got w is equal to x to the third over y squared. And we got x is equal to t plus 3. Y is equal to t squared. And t is equal to 1. It says we want to find our second derivative of w with respect to t. Use an appropriate chain rule. Evaluate the second derivative at the given value. Well, our chain rule for this says that we have the partial of dw dt is equal to partial of w with respect to x times dx dt plus the partial of w with respect to y. That shouldn't be a 2. Sloppy is one thing, but can't look like a 2. Partial of w with respect to y times dy dt. Okay. Partial of w with respect to x. Well, let's put this in a different form. We could write w is equal to x to the third, y to the negative 2. Because this y squared, we can move up on top. Anytime you move anything opposite in a fraction, the sign of the exponent changes. And if we take the derivative of this, partial of this with respect to x, the y to the negative 2 is a constant. So the derivative of x to the third, take the 3, put it out in front, and lower your power by 1, so it becomes 3x squared, y to the negative 2. Times dx dt, well, the derivative of x with respect to t, derivative of t plus 3 is 1. Plus the partial of w with respect to y. Well, again, the x to the third is now a constant, and the derivative of y to the negative 2, take your power, put it out in front, so we'll take negative 2, put it out in front, and lower our power by 1. So this becomes negative 2, x to the third, y to the negative 3. And then a partial of y with respect to t, well, y is equal to t squared, so the derivative of t squared is 2t. Okay. Well, let's do a little bit of simplifying. So this becomes 3x squared, and I'll take the y squared back downstairs, minus, and we got 2 times 2 is 4, so that goes up here, t, x to the third, and we'll put the y to the third down in the denominator. I'm going to double check that. 2t, x to the third, y to the third. Okay. So now, this is our first derivative. We want to plug in x is equal to t plus 3 and y is equal to t squared. So, excuse me, x is t plus 3, so this becomes t plus 3 squared over y squared. So we're going to have t squared squared. Again, the y is equal to t squared. I put that in for the y, and it's ra squared. Minus 4t times x to the third. So we'll have t plus 3 to the third. Over y to the third. So we'll have t squared to the third power. Now these up on top here, these both have a t plus 3 squared, so I can factor that out. Well, let me show the steps. Because we need to get a common denominator, and I was going to merge it all into one, but don't want to skip too many steps. This becomes t to the fourth. We're raising one exponent to another exponent, you multiply them. Minus 4t, t plus 3 to the third. Over, you're raising one exponent to another exponent, you multiply them. 2 times 3 is 6. So That gives us 3 times t plus 3 squared over t to the fourth, minus, that t cancels one of these t's, so I got 4 times t plus 3 to the third over t to the fifth. Well, I need to get a common denominator so I can merge them together, which would be t to the fifth. So I'll multiply my first fraction here, multiply top and bottom by t. So this becomes 3t times t plus 3 squared over t to the fifth minus 4 over t plus 3 to the third, or minus that over t to the fifth. Okay, now I'm going to merge them together into a single fraction. So I got 3t t plus 3 squared minus 4 t plus 3 to the third over t to the fifth. Now they both have a t plus 3 squared, so I'll factor that out in front. And let's see what that leaves us. Leaves us 3t there minus 4 times t plus 3 over t to the fifth. Now there was 3 t plus 3's here, so I took 2 of them away, and that left me just 1 t plus 3. Okay, so that gives us t plus 3 squared times 3t, negative 4 times t is negative 4t, negative 4 times 3 is negative 12, over t to the fifth. Equals. Now I'm going to go ahead and multiply this through. So t plus 3 squared. I'll go ahead and show the steps. T plus 3 times t plus 3. And this here, 3t times negative 4, or 3t minus 4t is negative t minus 12 over t to the fifth. T times t is t squared. T times 3 is 3t. 3 times t is 3t. 3 times 3 is 9. Negative t minus 12 over t to the fifth. And let me write this down because I need to continue it up above. Now I'm simplifying this, but the other option would have been to go ahead and take the derivative of everything as a product and use quotient rule and so forth. Which way is easier? That's quite questionable. If I screw up on the basic math in this example, then I'll say the other way would have been easier. This is just elementary algebra we're doing here, but that doesn't mean I'm going to get it right and not multiply something wrong. Okay. Equals. This is still dw dt. You can see sometimes changing it to t's is not so easy. So up on top we're going to have t squared plus, we had 3t plus 3t gives us 6t plus 9 times negative t minus 12 over t to the fifth. Well, negative t times t squared is negative t to the third minus 6t squared. I'm multiplying negative t through. Minus 9t. Negative 12 times t squared is negative 12t squared. Negative 12 times 6t is negative 72t. And negative 12 times 9 is negative 108 over t to the fifth. Now let me double check those. Negative t, okay, negative 12t squared minus 72t. Okay. Which gives us negative t to the third. Minus 6t squared minus 12t squared is minus 18t squared. Negative 9t and negative 72t is negative 81t. Minus 108 over t to the fifth. Well, now I can split these into separate fractions. So I got negative t to the third over t to the fifth minus 18t squared over t to the fifth minus 81t over t to the fifth minus 108 over t to the fifth, which gives us negative 1 over t squared minus 18 over t to the third minus 81 over t to the fourth minus 108 over t to the fifth. Well, this becomes negative t to the negative 2 minus 18t to the negative 3 minus 81t to the negative 4 minus 108t to the negative 5. Well, now we're ready to find our second derivative. So if you have t to a power, take your power, put it out in front, lower your power by 1. Well, we got a negative times a negative 2 gives us a positive 2. Lower our power by 1, that becomes a negative 3. Take negative 3 out in front, and that gives us a positive 4254. Let's see, 24, 2, yeah. Lower your power by 1. Take that out in front, and we got 81. What am I doing? 81. For 324. T to the negative 5 plus 540. T to the negative 6. Which would give us 2 over t to the third plus 54 over t to the fourth plus 324 over t to the fifth plus 540 over t to the sixth. Yeah, it does say to find the second derivative, so let's go ahead and merge these together. And you get a common denominator. The largest power is what we want to go with, so we want t to the 6. So let's multiply the bottom part by t to the third, so multiply the top part by t to the third. Here, multiply the bottom part by t squared, so multiply the top part by t squared. Here, multiply the bottom part by t, so multiply the top part by t. And this one is fine as is. So our second derivative, in simplified form, would become 2t to the third plus 54t squared plus 324t plus 540 over t to the 6, assuming no basic math error. Well, now they want us to plug in t is equal to 1. Which makes it real easy with the ones. So this is, because 1 to the third is 1, so it drops away. So we got 2 plus, and all of these t's drop away when you put 1s in there. So I got 2 plus 54 plus 324 plus 540 over 1 to the 6, which is 1. That gives us 56 plus 864 equals 0, 1, not, carry the not, 920, assuming no basic math error. Or basic algebra error, for that matter. So that wasn't that simple of a problem. I don't see any right there, but that doesn't mean anything. Okay, let's save that. Long problem. Switching that one to t's to begin with. They're asking us to do that. But I think wouldn't have been too bad, actually. Still would have been a lot of basic math to begin with. But basic algebra, I should say. Okay, let's look at our next problem. Here we have w is equal x to the third plus y squared, and x is equal to 4s plus 2t, and y is equal to 5s minus 3t. And it's at the point s is equal to 2, t is equal to 1. Instructions say find the partial of w with respect to s and the partial of w with respect to t using the appropriate chain rule, and evaluate each partial derivative at the given values of s and t. Well, I know I'm going to need, for the x here, I'll need the derivative of x with respect to s, which will be 4. Remember, the 2t will be a constant. And then the derivative of x with respect to t, and that's going to equal to 2. And then we'll have the derivative of y with respect to s, which is 5, and then derivative of x with derivative of y with respect to t is going to equal to negative 3. Okay, so first thing they're asking us for is the partial of w with, or wait a minute. What are they asking for? Yeah, partial of w with respect to s. And this will be the partial of I should have had the formulas up there so you could see them. Let me see. I have it right here. Well, maybe I don't. There it is. It's what you might expect. Oh, I had the wrong notation there. Partial of w with respect to x, and then partial of x with respect to s. I thought something was wrong when I was writing those down. I need to get more sleep on weekends. Try that again. The reason why is you can't treat those other variables like constants. This should be a partial of x with respect to s, and this is a partial of x with respect to t. You can't treat them like constants unless you're taking a partial. This will be the partial of y with respect to s, and this will be the partial of y with respect to t. Okay, so this will be the partial of w with respect to x, that's our first variable, times the partial of x with respect to s, plus the partial of w with respect to, now we're dealing with the other variable, which is y, times the partial of y with respect to t. Okay, partial of w with respect to x. Well, the y squared is a constant, so we just got 3x squared times the partial of x with respect to s. Partial of x with respect to s is 4. Plus partial of w with respect to y. So partial of w with respect to y is 2y. And times partial y with respect to t. Partial y with respect to t, there it is, negative 3. I'll grab a drink here. And, boy, that should be a t, that should be an s. There we go. Partial y with respect to s is 5. Okay, let me go over that again. Since partial of w with respect to x, which would be 3x squared, times partial of x with respect to s, which is 4, plus, and you can tell if it works because these are going to cancel and leave you the same things you see here. You can think of it that way. This is partial w plus partial of w with respect to y, which would be 2y, times the partial y with respect to s. And again, if you cancel those, it should give you this. Partial y with respect to s is 5. Okay, that looks right now. So that gives us 12x squared plus 10y. Now, we're going to plug in x is equal to 4s plus 2t, and y is equal to 5s minus 3t. So we're going to have 12 times x, which is 4s, plus 2t squared, plus 10 times y, which was 5s minus 3t. Which gives us 4s plus 2t times 4s plus 2t, plus 10 times 5 is 50s, 10 times negative 3 is negative 30t. So that gives us 12 times 4s is 16s squared. 4s times 2t is 8st. 2t times 4s is 8st. 2t times 2t is 4t squared. Plus 50s minus 30t. Now they, what do they want here? Okay, it says first find the partial. So I'm doing it correct. One other way you could do this is if all they're wanting was the end result, they just want us to find the value, the partial derivative at the given values, you could have plugged in your s and t up here and made it a lot easier. But they're wanting us to find this. So we got 12 times 16s squared plus 16st plus 4t squared plus 50s minus 30t. Which gives us, where's my calculator? There it is. 12 times 16. 192 s squared plus 192 st plus 48 t squared plus 50s minus 30t. And that's the first part. They wanted to find that partial. Well, now they wanted us to plug in s is equal to 2, t is equal to 1. Excuse me. So this becomes 192 times s squared plus 192 times s times t plus 48 times t squared plus 50 times s minus 30 times t. Let me double check that. S2 to 2, t is 1, so 1, 1, 192 times 4. 192 times 4 plus 192 times 2 plus 48 plus 100 minus 30. Okay, plus 182 times 2 plus 48 plus 100 minus 30. 1270. So that's the second thing they were asking for. Okay, well, let's go find the other partial now. Okay, so they're asking us to find the partial of w with respect to t. That's going to equal to the partial of w with respect to x times the partial of x with respect to t plus the partial of w with respect to y times the partial of y with respect to t. Now let me double check that. Okay, so those canceled. I'd be left with that. If those those canceled, I'd be left with that. Okay, that looks good. Partial of w with respect to x. The y squared is constant, so that gives us 3x squared. Times the partial of x with respect to t. Partial of x with respect to t is 2. Plus partial of w with respect to y. The x to the third is constant, so it drops away, so that gives us 2y. Times the partial of y with respect to t, which is negative 3. Which is going to give us 6x squared minus 6y. And let me factor that 6 out front. Then we got x squared minus y. And we're going to plug in x is equal to 4s plus 2t, and y is equal to 5s minus 3t. And so I got 6 times 4s plus 2t squared minus y, which was 5s minus 3t. Which gives us 6 times 16s squared plus 16st plus 4t squared. I already showed all those steps, so I'll simplify this a little bit. Minus 5s plus 3t. And then I'll multiply the 6 through, and that gives us 96 s squared plus 96 st plus 24 t squared minus 30s plus 18t. Assuming no basic math error. Okay. Well, now they want us to plug in s is equal to 2 and t is equal to 1. So we're going to have 96 times 2 squared plus 96 times 2 times 1 plus 24 times 1 squared minus 30 times 2 plus 18 times 1. And where's my calculator? Okay, 96 times 4. 96 times 4 plus 96 times 2. 6 times 2 plus 24 minus 60 plus 18. 558. Again, assuming no basic math error. Okay, let me save that. Now, notice the instructions here. It says first find a partial of w with respect to s and a partial of w with respect to t, and then evaluate. If all they wanted was just to find a value of the partial at a given point, again, it becomes a lot simpler. Instead of going through all these, right here, you plug in your value for s and t. You plug 2 in here, you plug 1 in here, and that gives us 4 times 2, which is 8, plus 2, which is 10. And then you plug that in for your x. But since they were wanting this, then that's why I went and did that step. I don't think I did that in class. As you can see, it's not very nice. Of course, I'm sitting there blah blah blahing. The question is, did I save that? $11.16. Yes, it did. Okay. Let's look at our next problem. And it says, want us to find a partial again. Here, instead of t's, we got r and theta, which you can probably envision where we'll be using that in the future. T is like when you're dealing with time and so forth, probably physics type problems. Okay, so use appropriate chain rule first. So here we have W is equal to x squared plus 3xy minus 2y squared. And we got x is equal to 2r plus theta. And y is equal to 2r minus theta. First thing is we'll use the appropriate chain rule to find these. Well, if I take the partial of x with respect to r, the theta is a constant, so it drops away, and derivative of the 2r gives us 2. Partial of x with respect to theta. Well, the 2r is a constant, so it drops away, and derivative of theta is 1. Now in this one, the partial of y with respect to r would be 2, and a partial of y with respect to theta would be negative 1. Now we'll also need some other, I guess I can go ahead and find them all while we're here. Learn to speak someday. Partial of w with respect to x. Well, the x squared becomes 2x. Now the y we treat as a constant, so the 3 and the y just remain, and derivative of x is 1. So 3y times 1 gives us 3y. And the negative 2y squared is a constant, so it drops away. Because the derivative of a constant just goes to 0. And then we'll take the partial of w with respect to y. Again, we treat the x like a constant now, so the x squared drops away. 3x just remains, that's our constant part, and derivative of y is 1, so that gives us 3x. Minus, and then this just has y's, so that's minus 4y. Let me double check that. Minus 4y, 2x. Okay, so now, first thing, I want us to find a partial with respect to r. So partial of w with respect to r is going to equal to the partial of w with respect to x times the partial of x with respect to r plus the partial of w with respect to y, our second variable, times the partial of y with respect to r. So partial of w with respect to x is right here, is 2x plus 3y, times the partial of x with respect to r, which is 2, plus partial of w with respect to y, which is 3x minus 4y, times partial of y with respect to r, which is 2. Well, we can simplify this a little bit. Double check my work here. Okay. 2x times 2 is 4x. 2 times 3y gives us 6y. 2 times 3x is 6x. And 2 times negative 4y is negative 8y. Which gives us 10x minus 2y. Now, but we know what x and y are. So we're going to plug in x is equal to, what was x? 2r plus theta. And y is equal to 2r minus theta. So partial w with respect to r, we got 10 times x, which is 2r plus theta, minus 2 times y, which was 2r minus theta. 10 times 2r gives us 20r. 10 times theta gives us 10 theta. Negative 2 times 2r gives us negative 4r. And negative 2 times negative theta gives us a positive 2 theta. 20r minus 4r is 16r. 10 theta plus 2 theta is 12 theta. Okay, now let's find the other one. And so we're going to find a partial of w with respect to theta. That's going to equal the partial of w with respect to x times the partial of x with respect to theta, plus the partial of w with respect to y times the partial of y with respect to theta. So let me scroll up so I can see everything. Partial of w with respect to x. That's our 2x plus 3y. Partial times the partial of x with respect to theta. Partial of x with respect to theta is 1. Plus the partial of w with respect to y is 3x minus 4y. Times the partial of y with respect to theta. Partial of y with respect to theta is negative 1. Do a little bit of simplifying here. That gives us 2x plus 3y. Negative 1 times 3x is negative 3x. Negative 1 times negative 4y is a positive 4y. Which gives us negative x. 3y plus 4y is 7y. And now let's plug in our x is equal to 2r plus theta. And y is equal to 2r minus theta. So partial of w with respect to theta is going to equal to negative 2r plus theta plus 7 times 2r minus theta. That gives us negative 2r minus theta plus 14r minus 7 theta, which gives us negative 2r plus 14r is 12r. Negative theta and negative 7 theta is negative 8 theta. Oops. Now they want us to find it using the by substituting in values. So part B, we're given w is equal to x squared plus 3xy minus 2y squared, and x is equal to 2r plus theta, and y is equal to 2r minus theta. It'll be the moment of truth if I can get the same answers as I did up above, or if I got a basic math error somewhere. So plug in 2r plus theta for x. So we've got 2r plus theta squared plus 3 times x, which is 2r plus theta times 2r minus theta, minus 2 times y squared, which is 2r minus theta squared. Might as well simplify this a little bit, I guess. When I square this, I won't show all the steps, but that gives us 4r squared plus 4r theta plus theta squared plus 3, and these are conjugates, so all I have to do is multiply my first parts together. 2r times 2r is 4r squared. Theta times negative theta is negative theta squared. Minus 2 times 4r squared minus 4r theta plus theta squared. Double check that. Sometimes when I start skipping steps, that's where I make more mistakes. Not saying I don't make mistakes anyway, but so I get 4r squared plus 4r theta plus theta squared. Multiply 3 through, so that gives me 12r squared minus 3 theta squared. Multiply negative 2 through, and I get negative 8r squared plus 8r theta plus or minus 2 theta squared. Okay, let me double check. Okay, 3, so for 12 minus 3 minus 8r squared plus 8r theta minus 2. Okay. Here we got an r squared, and here we got an r squared, and here we got an r squared. Well, is there any other r squareds? I think that's it. Negative 8 plus 12 is 4, plus 4 is 8, so we got 8r squared. Here we got an r theta. Here we got an r theta. So 4r theta and 8r theta is 12r theta. Here we have a theta squared. Here we have a theta squared. Here we have theta squared. So theta squared, that gives me a negative 2 theta squared, negative 4 theta squared. That's assuming I did my basic math right. We'll know in just a second. Okay, so we got two variables here. We're going to take the partial of w with respect to r. That's our one on the left up here. So I treat theta like a constant. So the derivative of r squared is 2r, so 2 times 8 is 16r. Theta is constant, 12 is a constant, and derivative of r is 1, so that gives me plus 12 theta. That looks good. That's what we came up with up here. Then I'll take the partial with respect to theta. I treat r like a constant, so 8r squared, that just drops away. The 12r stays there, and then derivative of theta is 1, so that gives me 12r minus 8 theta, which matches what we have up there. So I feel good about that. And you can see it's maybe a little bit easier. I don't know. Maybe about the same amount of work. I guess I should have checked to make sure that's all they wanted, not to plug in some kind of value or something. Let's go see. Let's see. Yeah, I guess that was it. Let's look at our next problem. Grab a drink here. So we got w is equal to e x squared y to the third z. And we got x is equal to 3s plus t, and y is equal to 2s minus 4t, and z is equal to 5s. And we'll find a partial of w with respect to s. So partial of w with respect to s. This is going to equal to the partial of w with respect to our first variable, which is x, times the partial of x with respect to s, the variable we're working with, plus the partial of w with respect to our next variable, which is y, times the partial of y with respect to the variable we're working with, which is s, plus the partial of w with respect to our next variable, which is z, times the partial of z with respect to s. Okay, so I'm looking up here at w, taking a partial of that with respect to x. Well, the derivative of e to a power is e to a power. That doesn't change. But then we have to multiply it times the derivative of the exponent. And we're taking a partial with respect to x, so the y to the third and the z are constants, and derivative of x squared is 2x. So this becomes 2x, y to the third, z, times the partial of x with respect to s. Well, t is a constant, so the derivative of 3s is 3, plus the partial of w with respect to y. Well, the derivative of e to the power is e to the power. That doesn't change. Times the derivative of the power, the partial of it with respect to y. Well, the x squared and z are constants, and derivative of y to the third is 3y squared. So we're going to have 3x squared, y squared, z. Times the partial of y with respect to s. Well, partial y with respect to s is 2. Plus, and then a partial w with respect to z. Well, derivative of e to the power is e to the power. Times derivative of the power with respect to z. Well, the x squared and y to the third are constants, and derivative of z is 1. So that just leaves us x squared, y to the third, times the partial z with respect to s, which would be 5. Now they all have an e to the x squared, y to the third z, so I'll factor that out. And here we got 3 times 2, which gives us 6x y to the third z. And here we got 2 times 3, which gives us 6 x squared y squared z. And here we got 5 x squared y to the third. Let me double check that. 6x y to the third plus 6x squared y squared z plus... Okay. Let's factor out what they have in common. They all have an x. They all have a y squared. And no, they don't have a z. Okay, so e to the x squared y to the third z times, and that 6 remains, that x is gone, y z plus 6x z plus 5 x y. Let me double check that. Okay, so if I multiply it back through, I'd have x, y to the third z, and I'd have x squared, y squared z. I'd have x squared, y to the third. Okay. Now I'm not going to actually simplify this. I'm not that much of a glutton for torture. But if we want to put everything back in terms of s's and t's, we would now plug in x is equal to 3s plus t, y is equal to 2s minus 4t, and z is equal to 5s. And I will plug them in, but I won't actually simplify it. So x is 3s plus t times y squared. Y was 2s minus 4t squared. E to the x squared, which would be 3s plus t squared times y to the third. So 2s minus 4t to the third times z, which is 5s. All that times 6 times y. Y was 2s minus 4t times z, which was 5s, plus 6 times x, which is 3s plus t, times z, which is 5s, plus 5 times x, which is 3s plus t, times y, which is 2s minus 4t. And that's not worth simplifying, so we'll leave it at that. Now, the ones in the book you may not find to be this nasty. They tend to go a lot with t's, like s plus t, s minus t, and so forth, which means that a lot of your derivatives are ones. But I think that doesn't really show the formula very well, so I don't like it when they do that. Because if you're learning it for the first time, you're seeing all these ones, it's like, where's that coming from? But if you see the 3 here, it's kind of obvious. You know, it's coming from right here. It's only 3 there in the x, y, and z. So I'd like to make it a little bit harder than the book there. Now let's find the other one. Okay, I'm going to write down what we have again. W is equal to e to the x squared, y to the third, z. X is equal to 3s plus t. Of course, the ones I'll put on the test will be ones that won't be hideous like this. It'll be more like what you see in the homework. Okay, and we want to take the partial of w with respect to t. Well, that's going to be the partial of w with respect to our first variable, which is x, times the partial of x with respect to t, plus the partial of w with respect to our second variable, which is y, times the partial of y with respect to t, plus the partial of w with respect to our third variable, which is z, times the partial of z with respect to t. Well, the partial of w with respect to x, the derivative of e to the power is e to the power. That doesn't change. Times the derivative of that with respect to x, or partial of that with respect to x, So y to the third and z are constants again, so that gives us 2x y to the third z times the partial of x with respect to t. Well, the 3s is a constant, so it drops away, and derivative of t is 1. Plus partial w with respect to y. So again, it'll be e to the x squared y to the third z times 3x squared y squared z. And I explained up above how I got that, so I won't say it again. Times the partial y with respect to t, which is negative 4, plus the partial of w with respect to z. So we've got e to the x squared y to the third z times x squared y to the third times the partial of z with respect to t, and there is none, so that's 0, so that drops away. So that works out nice. I factor that e to the x squared y to the third z out in front, and that's going to leave us 2x y to the third z. Negative 4 times 3 is negative 12 x squared y squared z. So let's factor out what they have in common. They have a 2, they have an x, they have y squared, and they both have a z. E to the x squared y to the third z. 2's gone, that x is gone, 2 of those y's are gone, so we got y minus 6 x, the y squared's gone, and the z's gone. Okay, well, let's plug in our values now. The x equals 3s plus t, y is equal to 2s minus 4t, and z is equal to 5s. So we have 2 times 3s plus t times y squared, which is 2s minus 4t squared, times z, which is 5s, e to the x squared. So we'll have 3s plus t squared times y to the third, which would be 2s minus 4t to the third, times z, which was 5s, times y, which was 2s minus 4t, minus 6 times x, which is 3s plus t. And again, I'm not going to spend any kind of time simplifying that. Though it's tempting to simplify what's in the brackets there, because I could simplify that, but that's our answer. And let me save that. And let's look at our next problem. This shows how to do differentiate implicitly. And we got x to the third minus 7xy minus 4x plus 3y squared is equal to 0. Now the key is have to have 0 on one side. So you have to get a 0 on one side. It doesn't matter which side. And if you do, then the other side is going to be our capital F. And to find dy dx is just a formula. We take the partial with respect to x over the partial with respect to y with a negative out in front. So for dy dx, we're going to have the partial of x over the partial of y. It's just our formula here. Okay. Well, we're going to take the partial of this with respect to x. What that means is we treat y's like constants. So this becomes 3x squared. The negative 7 in the y is a constant, and the derivative of x is 1. So negative 7y times 1 is negative 7y. Derivative of negative 4x is negative 4, and again, we're treating the y like a constant, so the 3y squared drops away. Now on the bottom, we take the partial with respect to y. X is treated as a constant, so x to the third drops away. The negative 7x is a constant here, and the derivative of y is 1. So that gives us negative 7x. The x is a constant, so the negative 4x drops away, plus 6y. And that's our answer. Now let's do this another way. Let's take they're wanting us to find dy dx. So let's take the derivative like we did back in Calc 1. This right here is, and I'll include a negative 7 in with my product rule, just so I don't have to worry about it. This is a product rule here, so p is negative 7x, and q is the y. So p prime, the derivative of negative 7x is negative 7. Q prime, the derivative of y is 1. But since we're taking the derivative with respect to x, then we have to add on our y prime, or our dy dx. So we're going to have p prime q plus p q prime for a product rule. So the derivative of x to the third is 3x squared, and then p prime, which is negative 7, times q, which is y, plus p, which is negative 7x, times q prime, which is y prime. The derivative of negative 4x is negative 4. The derivative of 3y squared gives you 6y, but then we have to add on our y prime. Again, anytime you're taking the derivative with respect to x and you got a different variable, you have to add on your y prime or your dy dx. Well, we'll get everything over one side, or everything with y prime on one side, everything else on the other side. So I'm going to take the negative 4 to the right side and these two over to the right side also. So I got negative 7x y prime plus 6y y prime is equal to negative 3x squared plus 7y plus 4. We'll factor our y prime out, and that gives us negative 7x plus 6y is equal to negative 3x squared plus 7y plus 4. And then we'll divide both sides by what's behind our y prime, and we're going to get y prime is equal to negative 3x squared plus 7y plus 4 over negative 7x plus 6y. Now I can factor that negative out and put it out in front, and you see we get the same answer. So this is another way that you could have done the those problems back in Calc 1. Of course, you didn't know about partial derivatives then, and you can see it's a little bit easier, isn't it? At least for this example. I wouldn't always claim it is. The minute I do that, I'm wrong. So let's take a look at this. And same formula. And I'm trying to think if I have room. I probably do. Okay, so we got a natural log of the cube root of 3x squared plus y minus 7x is equal to 0. Well, first off, we don't want radicals, so I'll rewrite that as 3x squared plus y to the 1/3 power minus 7x is equal to 0. And whenever you have natural log of something to a power, you can take the power and put it out in front. So I got 1/3 natural log of 3x squared plus y minus 7x is equal to 0. And I can even get rid of that fraction by multiplying everything by 3. So this becomes natural log of 3x squared plus y minus 21x is equal to 0. Okay, we got 0 on one side. That's key. So this will be our f. And to find our dy dx, it's going to equal to negative, and then the partial with respect to x over the partial with respect to y. Okay. Well, I got negative there. The derivative of a natural log of something is 1 over whatever's inside your parentheses. So we've got 1 over x squared, or 3x squared plus y, times the derivative of what's inside the parentheses. And we're taking a partial with respect to x, so the y is a constant, so that gives us 6x. And taking partial with respect to x, that's the minus 21 over, and try that again. I want the negative out in front. There we go. Let me double check that. Okay, yeah. Now we're going to take a partial with respect to y. Well, again, derivative of that is 1 over whatever is inside. That's the normal chain rule. Then times the partial of what's inside the parentheses. We're doing y now, so 3x squared drops away, so that gives us 1. And negative 21x drops away. So that's going to give us 6x over 3x squared plus y minus 21. Why do I keep putting that negative up on top? Over 1 over 3x squared plus y. Okay, let me double check that. Partial of that, okay, with respect to x, 6x minus 21. Yeah, it looks good. Okay, now we want to get rid of that complex fraction, so we're going to multiply everything by the LCM of all our inner denominators. So we'll multiply everything by 3x squared plus y. So that's going to give us, actually let me show the steps. Sometimes I start skipping steps, assuming you know them all, which most of you probably do, but maybe some of you need to see them. Minus 21 times 3x squared plus y over, negative out in front, 3x squared plus y times 1 over 3x squared plus y. Now when you do that, this cancels with that, and this cancels with that. Nothing left on the bottom, so we're going to have a negative applied just to the top. So we got 6x. Negative 21 times 3 gives us negative 63x squared. Negative 21 times y is negative 21y. And take that negative implied through, and I got negative 6x plus 63x squared plus 21y. I can factor out what they have in common, but that's our dy dx. So let me save that. Okay, let's look at our next problem. Grab a drink here. Now we're getting away from the stuff you saw in Calc 1. We got 5x squared, y to the third, z to the fourth is equal to 2. I'm going to take 2 over. So that gives us 5x squared, y to the third, z to the fourth, minus 2 equal to 0. Okay. Now we want to find differentiate implicitly to find the first partial derivative of z. And the formula is like you might expect. Take the partial with respect to x over partial with respect to z, and the partial with respect to y over the partial with respect to z, with negatives out in front. So, and again, this we have to have a 0 on this side. And over here is going to be our f. So partial of z with respect to x is going to equal to negative, then the partial with respect to x over partial with respect to z. That's just our first formula here. Okay. Partial with respect to x. Everything else is a constant. Of course, negative 2 always drops away, so we don't need to even worry about that. But the y and the z are constants, so they just remain. The derivative of x squared is 2x. So 2 times 5 is 10, so we'll have 10x, y to the third, z to the fourth. Over the partial with respect to z. Well, the x and the y are now constants, so they remain. And derivative of z to the fourth is 4z to the third. So put 4 out in front, and we got 20 x squared y to the third and z to the third. Now let me double check that. 4z to the third, yeah. This simplifies a little bit. I can put negative up on top actually now. The 10 and 20, that gives me a 2 down here. Here's an x squared, so that leaves me an x here. Those drop away, and I got a z up on top. And that's our answer. Let me double check that. X, y is gone, z. If I took my partials right, then that'd be our answer. Then I'll take the partial of z with respect to y. And that's going to equal to partial of y over the partial of z. Okay, so derivative of this, the negative 2 again drops away. A partial of this with respect to y, I treat the x and z like constants. The derivative of y to the third is 3y squared. So I'm going to have 15 x squared, y squared, z to the fourth. And partial with respect to z. The x and y are constant, so they remain. Derivative of z to the fourth is 4z to the third. So that gives us 20 x squared, y to the third, z to the third. Okay. And I'll put negative up on top. 15 and 20 both divisible by 5, so that gives us 3/4. X squareds cancel, leaves me a y down here and a z up here. And assuming I took my partials right, that's my answer. Okay, let's take a look at another one of those. I got sine of x minus z minus e to the x, or e to the yz is equal to 3y. I need to get everything over one side. So sine x minus z minus e to the yz minus 3y is equal to 0. I don't know why I torture myself by drinking a lot of pop when I'm making these videos. Have to have a 0 on one side. And if you do, then this will be your f. Okay, so we want to take the partial of z. Try to remember what they said. Okay, find the first partial derivative of z. Okay, so partial of z with respect to x. We're going to take the partial of f with respect to x, and the partial of f with respect to z. Okay, partial of this with respect to x. Here, there's an x inside the sine, so derivative of sine is cosine of whatever's inside, times the derivative of what's inside the parentheses with respect to x. The negative z is a constant, so it drops away, and derivative of x is 1. Now, we're taking the partial with respect to x, and yz, the e to the yz, there is no x here, so that drops away, and the negative 3y drops away. Now taking a partial of this with respect to z. Well, again, derivative of sine is cosine. So that's cosine of x minus z. And then times the derivative of what's inside the parentheses with respect to z, which would give us negative 1. Now this has a z in it. So the derivative of negative, or the derivative of e to the yz is e to the yz, times the derivative of the exponent with respect to z, which would give us y. Because again, y is a constant, and derivative of z is 1. So y times 1 is y. This doesn't have a z in it, so it drops away. And I don't think there's much simplifying I can do here besides get rid of those 1's. So we're going to have cosine of x minus z over, I'll put negative cosine, I'll put it up on top, cosine of x minus z minus y to the yz. Assuming I took all my partials right. Okay, partial of z with respect to y. That's going to equal to negative a partial of f with respect to y and a partial of f with respect to z. in fraction form. Partial of this with respect to y. The sine x minus z, there's no y in that. That drops away. And then the derivative of, well, this is a negative. E to the yz, the derivative of e to the yz is e to the yz, times the derivative of the exponent with respect to y. Well, the z is a constant, and derivative of y is 1, so 1 times z is z. Minus 3. And then the partial with respect to z would give us cosine x minus z times negative 1 minus e to the yz times y. I already went through that on this one. I was just taking derivative again to double check myself. That negative I'll carry through up on top, and that gives us z e to the yz plus 3. And down below we have cosine of x minus z, negative cosine. Did I drop the negative over here? I sure did. That should be a negative right there. Then I could have made everything positive. But good thing I did my derivative again. I found that error. Minus y e to the yz. There we go. Assuming no basic math errors, that's our answer. Some days I do better than others in not making any basic math error. I could have a script in front of me when I'm creating these, but that would take away the fun of them, then I wouldn't do them anymore. Okay. Let's look at our last one. Yeah. So we got tangent of xyzw minus xy plus 5wz is equal to 3. Now we won't get 0 on one side. Not that numbers mean anything, but xyzw minus xy. I guess I'd go read the directions, make sure it's still wanting implicit differentiation. Yes, first partial derivative is w. So again, you have to have 0 on this side, and then if you do, this will be your f. So the partial of w with respect to our first variable, x, is going to equal to negative partial of f with respect to x over the partial of f with respect to w. Okay. Well, the tangent here has an x in it, so the derivative of tangent is secant squared. Then we'll have x, y, z, w times the derivative of what's inside the parentheses with respect to x. So y, z, and w are constants, and derivative of x is 1, so that gives us y, z, w. Minus y. Again, I'm taking the partial with respect to x, so the y is a constant, and so the derivative of x is 1. This doesn't have an x, so it drops away. This doesn't have an x, so well, it's a number, so it drops away anyway. Over the partial with respect to w. Well, the derivative of tangent is again secant squared. That doesn't change. That's just our normal chain rule. Times, and then the derivative of what's inside the parentheses with respect to w. And x, y, and z are constants, and derivative of w is 1. So that gives us x, y, z. The minus xy here doesn't have a w, so that goes away. And then derivative of 5wz, the z is a constant. Derivative of w is 1, so that gives us plus 5z. And I won't do any kind of simplifying beyond that. That's our answer. Okay. Let's take the partial of w with respect to y. That's going to equal to negative partial of f with respect to y over the partial of f with respect to w. I'm not going to find w, the partial with respect to w again. I'll assume my first one here is correct. Okay, partial of f with respect to y. Derivative of tangent is secant squared. That doesn't change. x, y, z, w, times the derivative of what's inside the parentheses with respect to y. So the x, z, and w are constants now, and derivative of y is 1, so that gives us x, z, w. Negative xy, the x is a constant, derivative of y is 1, so that gives us negative minus x. There's no y here, so it drops away. There's no y here, so it drops away. Well, it's constant anyway. Never mind. Over, then the bottom stays the same. Times x, y, z plus 5z. Okay, now let's take the partial of w with respect to, what's our next letter? Z. And you can guess the formula. There we go. So, bottom part is as is, doesn't change. Okay, partial of f with respect to z. Derivative of tangent is secant squared. X, y, z, w. We're taking the partial with respect to z now, so the x, y, and w are constants. So the derivative of z is 1, so it's x, y, w. Taking the partial with respect to z, there is no z here, that drops away. 5wz, the w is a constant, the derivative of z is 1, so that becomes plus 5w. And negative 3, of course, drops away. And that's our answers. So let me save that. It's a good thing I was getting ready to float away here. Oops. Time to stop my recorders and play song pop while this is processing.